Hello students, in this video we'll find a formula for the curl of two vector fields. Let's consider the curl, so that's del cross a vector field v cross a vector field w. So let's do this systematically. So this is going to be del cross the sum over ijk, I, j, and k of epsilon I, j, k. And then I'll have a vi, and then I'll have a wj, a delta k hat. Now remember what the definition of del is. So recall that del is the sum over a different index, let's call it over an index, let's say r, of partial xr, and then times what? Delta r hat. And so what we're going to do is so let's write this out. So we're going to have, this is exactly going to be the sum over r, and then we're going to have partial xr delta r hat, and we're going to cross that with this expression over here, the sum I, j, and k, epsilon I, j, k, v, I, w, j, delta k hat. And so what we're going to do is we're going to do the xr derivative of this expression over here, and then we're going to cross delta r and delta k. So let's do that. So we're going to have the sum over r and I and j and k. And we'll have a new index for the cross, so I'm going to put an s over here for my new index for the cross. We're going to have epsilon I, j, k, and then we're going to have the xr derivative of vi, w, j. That's easy to do. We're just going to use the product rule on that. And then delta r cross delta k is the sum over k and r and s. So we have that over here. And what we have, we'll have an epsilon, then we'll have a rk, and then an s, rks, and then we'll have a delta s hat, Beautiful. Now what we have over here is I'm going to switch the indices over here to use the match-mismatch identity. Okay? So let's think about how we do that next. So what are we going to have? So by match-mismatch, what I'm going to do is I'm going to write this. Let's write this over here so we can figure out exactly what we have. So epsilon I, j, k. And this, I'm going to flip this k and the s around. So this is going to be epsilon r sk with a negative sign. So this expression over here that we have in our sum is exactly the same as this expression over here. Is equal to what? Is equal to negative. And then we'll have the match-mismatch identity. So I'm going to have a delta IR, delta JS minus delta IS, delta JR. And so we'll flip the signs because we have a negative. So I'll have a delta IS, delta JR minus delta IR, delta JS. So that's what our expression will give us. And so let's do the product rule over here too. So we're going to have this sum over here. We're going to have the sum over a whole bunch of indices over I, j, k, r, and s. And then we're going to have what? We're going to have delta IS, delta JR minus delta IR, delta JS. And then we're going to have the product rule over here. So I'm going to have a VI, W, partial WJ, partial XR. And then I'm going to have a plus partial VI, partial XR, WJ by the product rule, and then a delta S hat. All right, so we're going to break this into, we have 4 terms to handle over here. So let's label these terms, let's do the terms one by one. So the first term I'm going to handle is this term over here. So let's do that term first. So what will that be? So I gets replaced, I'm going to replace all the s's with I and all the r's with j. So I'm going to have no more s's and no more r's. I'm going to have the sum over ijk, And so remember, the s is going to turn into I, r is going to turn into j. So I'm going to have a vi. Then I'm going to have a partial wj over what? Over, r gets replaced with what here? R gets replaced with j. So that's going to be a partial xj. That's my first term over there. And then I have a what? Now I have a what is this going to be? So now my s's get replaced with what? My s get replaced with I. So my delta s turns into a delta I hat. And what happened to my k when I did this over here? So when I do the match-mismatch, the k goes away, so I'm no longer summing over k. So the k summation is going to go away, so we're going to remove that variable k. So that got removed when we did match-mismatch, so the k goes away. Okay, so this removes k, so there's no more k. No k, we trace over k. Good? That's the first term. Let's do the second term over here. The second term over here, we're going to do this and this. What will that give us? So now again, the same thing is true. The s is going to turn into i's, the r's are going to turn into j's. Then we're going to have plus what? Plus the sum over i and j. And then what we have over here, so I'm going to have a vi, wj, partial xr. And so now the what? I did that term already, so we don't want to do that term. We want to do this term. Sorry, we should do this guy next. Let's do this one over here. So now we're going to have what? So we're going to have partial vi. Now xr, what does r get replaced with? R is going to get replaced with j. So I have a partial xj. And then we have a wj. And then that gets replaced with what? S gets replaced with I. So I have a delta I hat. Okay, good. And so now we do the negative terms. So we have two negative terms to consider. So let's do maybe this, what am I missing over here? Let's do this first negative term over here. So minus the sum. Again, what's going to happen over here? I is going to turn into what? R, and j is going to turn into s, or s is going to turn into j. So I'm going to sum over I and j, the sum over I and j of what? So we're going to, and those are negative, so I have a vi, that's fine, vi. Then I'll have a wj, partial wj, and then I have an xr. The xr gets replaced with I, so that's going to be a partial xi. And then this is in the direction of what? Of delta s, but s gets replaced with what here? S gets replaced with j, so I'm going to have a delta j hat. And I get one more negative term over here. What's the last negative term we're going to get? The last negative term we're going to get is going to correspond to these terms over here, right? So what are we going to have? We're going to have minus the sum over I and j, And then we have a partial vi, partial xr. So it's going to be partial vi, partial xr is going to turn into what? xr is going to turn into what? xr is going to turn into xi, partial xi. And then I'm going to have a delta wj, so wj stays the same. And then over here, the delta s is going to turn into a j, so I have a delta j hat. Good. Now we have each of these four terms. We have to realize what these four terms are over here. So when we sum over j, what we have over here is this first vector field over here is a vector. So this, when I sum over j, summing over j, that's basically just the divergence of w in the direction of what? In the direction of v. So this first term over here is the divergence of w in the direction of v. Plus, now what do we have over here? Now we have wj xj, I'm summing over j, that's the directional derivative in the direction of wj, because I have wj, so this would correspond to w1 partial x, plus w2 partial y, plus w3 partial z. That's the directional derivative. So this is the directional derivative of what? So this is the directional derivative of what? This is the directional derivative, so that was written as w dot nabla for directional derivative in the direction of v in the direction of w. Great. Now we have what? Minus. Over here, we're going to have the directional derivative in the direction of v of w. So this is going to be v dot gradient, directional derivative in the direction of v of the vector field w. And then this over here is going to be what? That's going to be, oh, right here, that is the divergence of v. So it's going to be divergence of v in the direction of w. So there's our vector identity. So this expression over here is what we get when we do the curl of two vector fields. So the curl of the curl is given by this formula. And we can see how vector notation, the match-mismatch identity, helped us simplify this dramatically by tracing and by rearranging the terms. Thank you very much.